Roughly 4.5 billion years ago, a giant planetoid slammed into the primordial Earth. Some of the broken pieces formed the moon, while other pieces joined the newly formed Maine asteroid belt. Thankfully, impacts like that don't happen all the time. But smaller impacts from asteroids still do. And they leave scars known as impact craters. These impacts shape the planets as we know them today, giving us craters which are windows into otherwise impenetrable and distant surfaces, giving us surface ages, geologic history, subsurface mineral compositions, and more. While many craters tend to have a basic bowl shape, like Meteor Crater here in northern Arizona, I'm studying a more complex crater called Essential Pit Crater, or CP Crater, one of the rarest and least understood kinds. We once thought that CP craters could only form on icy surfaces, like on the moons of Jupiter and Saturn. But we need a new model to explain the CP craters on rocky surfaces, like on the Earth, our moon, or Mars. Though Earth is obviously the easiest place to get to, we only have one potential CP crater, and it is largely inaccessible due to the city of Nordlingen, which is inside of it. It was built over 1,100 years ago. Aside from Earth, we have the best data from Mars, so my research focuses on examining CP craters there. To get the most comprehensive picture possible, I'm mapping them in great detail, looking at landforms, minerals, elevation changes, faults, and more. Findings from my first crater, Asira, contradict at least two current formation models. One model suggests the pit formed when the middle of the crater collapses, whereas in Asira, here, my data shows that the pit rim was formed by uplifted bedrock from below the crater floor. The second model suggests the pit was formed sometime after the crater formed with a watery explosion, but my data shows that melted rock caused by the heat of the impact actually flows into the pit, meaning that the pit was formed by the impact event before the melted rock quickly cooled. While it seems that the formation process of CP craters differs on icy and rocky surfaces, Asira still shows definite signs of ice interaction. In fact, dating CP craters might be a great way to learning about ancient climate change on Mars. Thanks to the data from Mars, I'm on my way to creating a new formation model that can be used for CP craters on any rocky surface. Craters are so remarkably information-rich that they are crucial to our understanding of the solar system, and CP craters are my piece of this puzzle. Thank you.